Hello everyone, in this video I'm going to be showing you guys how to find for the arc length of the curve y is equal to ln of cosine x from x is equal to 0 to x is equal to pi divided by 3. And first I would like to demonstrate how to actually find for the arc length of a curve. Okay, so let's say that we have a function y is equal to fx. And let's just say that this curve looks something like this. We're going to be finding for the arc length of this curve from x is equal to a to x is equal to b. So that would be this length here. And the way we're going to do this is, hold on, I made that kind of too thick. The way we're going to do this is by taking one small portion of this whole length. So I'll take this part, and this is a straight line that I just drew. We're first going to find for this length, which we'll call a ds. And so so I'll zoom in on this part. If I draw this more bigger, then it'll look something like this. So like this length is ds, and we have this length, which we'll call a dx, and this length, dy. Using, this is a right triangle, so we can find that ds is equal to the square root of 1 plus, is the square root of dx squared plus dy squared. And we're going to divide and also multiply dx. And if we do that, we can have something that looks like this. I think you can see how I got from here to there. I just divided by dx. So if the divided by dx goes into the square root, then it'll look like this. And I also have to multiply dx, which just is on the outside. And we have this length is just one small part of the whole length. So to find for the whole length, we're going to take the integral. So taking the integral, it basically means that we're going to be adding all of these tiny little lengths together. So we have the integral from a to b of ds, which is equal to this, the square root of 1 plus dy divided by dx squared times dx. And now, so this is the formula for finding for the arc length of the curve, of a curve. Okay, so now I can just put in y is equal to ln of cosine x. And when we're finding for the arc length of a curve, we don't necessarily have to really draw the function or the curve if we already know the formula for it. So a in our problem would be 0, and b would be pi divided by 3 of the square root of 1 plus dy over dx would be the derivative of our function, which would be cosine x multiplied by the derivative of cosine x, which is negative sine x, okay, now we don't really need this part, so I'm just going to erase it. And as you can see, negative sine x divided by cosine x would be equal to negative tangent x. If we square that, we have the square root of 1 plus tangent squared x dx. Well, if you're not familiar with the trigonometric identities, 1 plus tangent squared x is actually equal to secant squared x. So that would leave us the integral from 0 to power 3 of the square root of secant squared x dx. But since we have the square root, we can just cancel out. We can just get rid of the to the power of 2. And we know that the integral of secant x, I'm going to work up here now, since I don't have any space. Actually, I'll just erase this problem. And I'll also erase everything else. Okay, so this is where we left off, and to integral secant x, we're going to multiply secant x plus tangent x, and also divide it by secant x plus tangent x. That would give us secant x multiplied by secant x plus tangent x for the numerator, and for the denominator we would just have secant x plus tangent x. And now we're going to use u substitution rule by setting u is equal to secant x plus tangent x, and that would give us the du as secant x times tangent x plus secant squared x dx. As you can see, this whole thing is the numerator, including the dx, because if we expand the numerator. So we're just going to replace this whole thing that is circled in orange with du. And secant x plus tangent x, we're going to replace it with u. Since we used u substitution rule, we would also have new intervals, right? If we put in pi divided by 3 for x in u, we would have secant pi divided by 3 plus tangent of pi divided by 3. Secant pi divided by 3 is equal to 1 divided by pi divided by 3. 1 divided by cosine pi divided by 3, I'm sorry. And plus tangent pi divided by 3 is the square root of 3. Cosine pi divided by 3 is 1/2, and we have 1 divided by cosine pi divided by 3, so that would give us 2. And also add the square root of 3. And so we're just going to replace 2 plus square root of 3 instead of having pi over 3. Okay, now our other interval is 0. So if we put in 0 for the x in here u, we have secant 0 plus tangent 0. Tangent 0 is equal to 1 divided by cosine 0 of 0 plus tangent 0 is just 0. Cosine 0 is 1, so 1 divided by 1 is just 1. Plus 0 is nothing, so we're going to replace 0 with 1. And so now we found our new interval. Now we're going to take the integral of 1 divided by u, which is ln absolute value of u. And now we're going to put in our interval. 1 and 2 plus the square root of 3. If we put in u is equal to 2 plus square root of 3, we have ln of 2 plus the square root of 3 minus, if we put in 1 for u, we have ln 1 But ln1 is just equal to 0, so we don't have to worry about that. And that would make our final answer as ln of 2 plus the square root of 3. Thank you for watching, everyone. In this video, I found the arc length of the curve y is equal to ln of cosine x. And I did have to erase a lot of things because I don't have room on my whiteboard. But I hope you understood my explanation and have a great day. Thank you.